Hello there again, and welcome to Animal Nutrition Unit 4, Procedures in Feed Formulation. And the recommended reading for this section of notes is Chapter 4 in your textbook. And it does do quite a complete job of taking you through a lot of the options in formulating rations that are available out there, as simple as the Pearson square method, which we will show you some examples of in this section, as well as an algebraic method, which I just list but do not really do much examples of, as it's much more involved and difficult. And then talk just briefly about how we'll use computerized assistance in ration formulation, which is obviously much more accepted and utilized in today's industry. So let's get into this section. We can give you the objectives here, and we'll talk about feeding standard tables for various livestock, and we've looked in previous sections about what feeds might be included in a ration and how to come up with feeding requirements and needs, and so we'll reference back to some things that we've already talked about, and then begin to build on those. We'll talk about methods of diet formulation, a few things that I just discussed, and the purposes of using maybe a premix and how it can be formulated as you talk about multiple ingredients in a diet, and using a simple Pearson method approach and so forth. So let's jump into the content here that we've got in Unit 4. The first thing that we need to understand when we begin to now balance rations and put things together in terms of is feeding needs or meeting the daily nutrient requirements of your animal. So how do you come up with that information? Well, materials that are needed is nutrient requirement data. NRC is listed there next. That's the Nutrient Research Council, and those folks establish the actual crude protein, energy, caloric intake, vitamin, mineral needs of all farm animal species out there, based upon scads of research that most of it comes out of university and extension research projects, and then through meetings that those folks have to establish worldwide really what the nutrient requirement needs of our animals at different sizes, ages, weights, stages of development, reproductive status, lactation, work, basically everything that we're going to be talking about in the class. Most all of that is based on NRC data. So that's the first component that you need, is you need to understand what the nutrient needs are that you are balancing for. Secondly is some feed analysis data. Some of that may come from the same source. We talked about doing feed analysis in the last section in Unit 3, and why it's so important to get proper lab data on your forages and so forth, and this is where we begin to apply that information. In addition, you'll see a lot of different tables in your textbook that we're going to begin to use in class, and balancing these rations is some book value numbers. If you don't have actual lab tested information, you can use some book value or averages for corn or hay or whatever it might be that you may be using in your ration. So those are two specific materials that or information that you're going to need to compile before we get into building an actual ration. So procedurally, if you, those of you that like lists, this will help you. So consult any reference material that you think you might need, that NRC, extension research, whatever it might be. Identify and prepare a list of important nutrient requirements then that you're going to be looking at balancing for. Next is think about available feedstuffs, and I can't emphasize this enough. There are a lot of feeds that we can put in the diet that balance a ration out, but they may not be easily available for you to get or get then cost prohibitive to be delivered to your operation or to your feed mill. So determine what's actually available and realistic for you to feed. Then take that information and list a nutrient composition of those available feeds, crude protein, energy, TDN, things of that nature, and then balance the ration and follow the guidelines. And DMI here stands for dry matter intake, referencing back to that second to last slide in Unit 3 that I mentioned, is animals eat 1% of their body weight in dry matter. So we need to have a realistic idea of how much feed, let's say, a 1,000-pound horse is going to eat, or how much feed a 600-pound steer is going to eat, so to speak. So you have to understand how much feed is going to be consumed. Then I've just listed a few examples like crude protein, total digestible nutrients or TDN, and some other things, but mostly we'll stick to the basic easy things here in order to get a simple grasp on what's going on with regard to simple ration balancing. Procedurally then, once you think you have the ration put together, check it for proper mineral vitamin concentrations. One of the things is, this was part of something that I did early in my career as a profession, is balance rations. You really need to come back and check and make sure that you have proper mineral and vitamin feeding levels, and then recheck the ration. Make sure that if you have any deficiencies that you identify, you address and correct those deficiencies. And coupled with that, if you have excesses in the diet, address those as well. We don't want to waste any more feed or feed nutrients than necessary. Simply, margins are too tight in today's animal agricultural economy. You just can't waste any nutrients that are in the rations today. In addition, we have to be environmentally friendly. Consider then, is it going to be an acceptable feed as you put it together? Will the animals eat it? You can put lots of things in the diet that look good on paper, but an animal simply won't consume. Then also think about or consider economics. Put a budget to it. Does it work economically? Is it as cheap as you can feed that animal and still attain the outcomes that you're looking for from a productivity perspective? Calculate the cost, whether it's cost per ton, as listed there first, or the second one is cost per head per day. And I will be a stickler as we go through starting to balance these rations, is have you done an economic analysis of your diet? Do you understand what it will cost on a per ton of feed basis, or do you understand what it will cost on a cost per head per day basis, as we look at calculating a budget here and trying to keep costs under control? And then, are there going to be any other things added, not added in the ration, that's going to be available for the animal to consume? For example, some of you might like to put lick tubs out there for your animals, or salt blocks, or mineral tubs out there somewhere. Are there any other things that are not included in the diet that we should maybe think about? Do they need to be included in the ration, or do we consider them just supplementations? So some simple techniques. We can formulate our own very simple rations considering just one nutrient. We're going to get into that here in just a second and go through an example kind of nice and slowly, hopefully show you a little bit about how that works. And we'll then use some of these methods and make it a little bit more complex. And as we get to some of that stuff, those are things that we'll get together in class and discussion and our assignments, and consider how to put together maybe a more complex diet. I mentioned that there are algebraic equations, and you can follow along in your textbook and really look at, those of you who like to use algebra or are good at that mathematic technique. That's a way in which you can balance a ration with multiple ingredients and multiple nutrients involved and come up with a on paper ration that you might be able to apply out there in your own backyard. What I'm going to show you just very simply is what we call the Pearson square method, which is the easiest of all the ration balancing techniques, and I think a good baseline to start for all of you that we're going to have here in the class. Some precautions though whenever we consider the Pearson square method. We can only use 2 feed materials or 2 feed ingredients at a time. They may be simple ingredients like corn or alfalfa hay or oats, or it could be a mixture. And back whenever the Pearson square method was the primary method of balancing rations, you would just have to continue to make mixtures. You would make a corn and soybean meal mixture, and then you would take that mixture and then maybe add something like dried distillers grains into the diet. You would take that mixture and then add your maybe minerals or corn silage to the diet, and continue to make mixture upon mixture upon mixture. And a ration got very, very complex, and a lot of pieces of paper, as you can imagine, going into completing a somewhat balanced diet using the Pearson square method. So you'll see that example as we go through here in the next few slides. You're going to see a number that's created that always has to be in the center of the box. That number must be intermediate of the two numbers on the left side of the box. Again, we'll show you here in a subsequent slide example. If that number is not in the middle of the two numbers on the left, so if we're balancing a diet, a ration for a 12% crude protein diet for horses, you need at least one ingredient higher than 12% crude protein and one ingredient lower than 12% crude protein in order for the Pearson square method to work. If you find a question or example out there that I propose to you and that is not the case, the very simple answer to that is that ration cannot be done with the Pearson square method and these two ingredients. So those requirements then are expressed as a percent or a proportion, and we'll get into an example here in a second. Again, we're going to use two feed sources, so let's start our example here. We're going to complete a formulation of a 16% crude protein swine diet using 9% crude protein corn and a 36% protein supplement. Let's just say we purchased at our local farm supply store, or your local favorite feed supplier, whatever it might be. So we're going to just use those two ingredients in this example. So like I said here, we're going to start with that 16% crude protein in the middle of our Pearson square, nice and big. If you like to put a percentage there, that's fine, but as we go through, I'll talk about some of the limitations and hiccups that students run into when learning this very basic method. We're going to put our two ingredients on the left side, top and bottom of the Pearson square. You're going to see your 9% crude protein corn up there on the top and 36% crude protein supplement there on the bottom. Now, you can run into some of your own preferences here. I tend to put the lower of the two ingredients on the top and the higher of the two ingredients on the bottom. It's just so that I do the same procedure every single time in order to hopefully eliminate mathematical errors for me. As we add to the next slide then, we're going to subtract diagonally across this Pearson square. So you're going to subtract 9 from 16, and you're going to subtract 36, or you're going to subtract 16 from 36. So you're going to subtract diagonally across the square as signified by the arrows that are there. Give you answers that we see on the right side of the screen now as 20 parts or 20 parts corn and 7 parts supplement would be needed in order to meet that 16% crude protein diet. And we'll continue to add to this slide here, so hopefully you'll understand when we get to the end how this works, and we'll do plenty of practice in class. Understand that as you subtract across the diet, that ingredient does not follow that though. Lots of students get confused that if I subtract 9 from 16, that's going to be 7 parts corn at the bottom right hand side of the slide. It's not. It's 7 parts supplement. If you subtract 16 from 36 and go diagonally, most assume that that's going to be 20 parts supplement. It's corn. So if you put corn on the top, corn stays on the top. If you put supplement on the bottom, supplement stays on the bottom. Even though we subtract diagonally, the ingredients stay on either the top or the bottom. So that's a pitfall that many students run into, and that's hopefully I've indicated it well enough here with the arrows that you get an idea what we're trying to propose to you here and procedurally how this works. So let's move to the next slide and see how we then complete the diet. We take that 20 parts corn and 7 parts supplement, and we add those together to get 27 total parts or proportion of the ration. You say, well, I don't really know what that means yet. Let's get to the next slide. Well, if we take 20 parts corn and we divide it by the 27 total parts in the diet, that comes up with telling us that the ration should be 74% corn. And if we take 7 parts supplement and divide it by the whole, that should be 26% of the ration should be supplement. If we have done all of our math correctly, then that's going to give us that 16% crude protein diet that we've put there in the center of our Pearson square. Bottom line, one thing again to reinforce here is ignore negatives. I understand that if you take 9 minus 16, you get a negative 7. Ignore that negative. Don't worry about it. Even though the many other mathematical rules that you've been taught would say that's going to be a negative 7, not in this instance. And don't worry about the percentages here. Even though it's 9% crude protein corn, it's just not 16 minus 9 and 36 minus 16. Don't worry about the percentages when you cross that Pearson square diagonally there. The only time we're going to begin to use percentages is when we get towards the end here, where we use the 74% of the diet is going to be corn and 26% of the diet or mixture is going to be supplement. Let's finish example up here and go back to our ration and say, suppose our pigs eat 5 pounds per day. If we take that 5 pounds per day intake and multiply it by 74% of the diet corn, as suggested by our Pearson square, that means that pig's going to need to eat 3.7 pounds of corn a day, and we take that same 5 pounds intake multiplied by the other 26% of the diet of supplement. That means we need to feed him 1.3 pounds of supplement per day to match that 5 pounds intake and that 16 pounds or 16% crude protein diet. That's how feed formulation works, just real quickly. And I'll invite you, I'm sure some of you maybe have practiced this already, maybe in a high school animal science class, maybe even in a biology class. I've seen this done before, but you can certainly go backwards in the slide set here and recheck your math, recheck your examples, and see if you come up with the same answers that we have here. But that's very, very simply how you can create a diet. And I've seen and had many students over the years that say, hey, I can do this now at home. I can check and see if my horse ration is balanced with my 12% oats and maybe 14% hay or 16% hay. I can really check and see if I'm somewhat accurate on what I'm feeding, rather than the by guess and by golly method of just a can of this and a scoop of that, so to speak, and however much hay that you estimate that they're eating. So this is a very simple way, once you get this mastered, in order to calculate a ration and see if you're in balance. There's the next couple slides are going to show you some examples that I think will take over in class in discussion in 3 or more feed sources. For example, a corn, soybean meal, and tankage mixture in a 3-to-1 mix. We may try that one. We may use a ration with some fixed ingredients in here, preparing like 1,000-pound diet from corn, soybean meal, and fixed ingredients. And you can read through some of the things that to be prepared for when we get to class here, so that some of these things make sense. But again, always when you get to the end, make sure that the percentage for the center of the square is correct. That could be TDN, by the way. That could be any nutrient that we want to balance for. We just chose to use crude protein in this example. Always then go back and recheck your ration. Here's that example that we're going to try in class. We're going to put together a 2,000-pound diet, 20% crude protein diet for broilers. And I would invite you to see if you can figure this out at the end, or figure this out on your own before you come to class. We're going to have a fixed amount of meat and bone meal that's 50% crude protein of 100 pounds in the diet. We're going to feed 40 pounds of that 2,000-pound diet of fish meal, 40 pounds of the diet is going to be alfalfa meal. You can see the crude protein levels of those two things listed right there. 30 30 pounds of the 2000 is going to be mineral premix, and 20 pounds of a vitamin premix. And again, those premix things are ingredients put together and generally bagged by your local feed company that just are added to the ration. So we're going to come up with a 20%, hopefully 20% mixture, calculating in there with corn, and then 44% crude protein soybean meal. So that's one for you to practice at home, and we will also go through in class. So if you get stumped on it, we'll work on it in class, and don't let it frustrate you. But we're aiming for a 2,000 pound mix, and so the question marks there is how many pounds of corn are we going to need, and how many pounds of soybean meal are we going to need to put in this ration in order to complete that 2,000 pound mix. I list there real quickly just substitution of ingredients, and I want to chat just real briefly about that, because again, as we start to think about the economics of some of these diets, is maybe you want to find something else to put in the ration, or maybe you change hays at home and you test it and you find out that it's a little bit different crude protein percentage, or maybe you decide to change from using corn in the diet to dried distillers grains, or you want to add beet pulp to the diet and you substitute different ingredients in. Understand that that changes the diet potentially, and you can't always just substitute pound for pound. So it needs to be then readjusted, rebalanced, and rechecked to make sure that all of your ration and nutrient needs are met. Just real quickly on computer-assisted formulation, and obviously we're not going to go into that detail here on a slide set. I would more than confuse you, but understand that there are a number of programs out there. We're going to practice a few of them. There's a couple that we're going to work on, one with swine and one with beef cattle, that's essentially a Microsoft Excel program that a couple extension universities out there put together that has a very limited feed library, but it can allow us to experience how to put that together. That they have all the nutrient profiles in their feed library, they have the species nutrient needs in their library already, and all you have to do is make some selections and then understand what you're looking at and begin to add the feeds and start to balance things out. Again, as always, we always prefer lab analysis on all forages. All of your computer-assisted formulation is going to have a library or book value number, so to speak, on corn silage or alfalfa hay. That will work in the absence of a lab analysis test. But if you can have your feed sampled, I would always encourage you to do that. Have your local feed nutrition professional sample it, send it to a reputable lab, have it analyzed, and use that data. Use your own data in your formulation. Don't use the book value unless you have to. So those programs are going to calculate nutrient requirements of the animal that you're going to feed all automatically. It will many times flag or give you some kind of notification that you're delinquent or short or even over some of the nutrient profile needs. We're going to look at a number of different options out there in terms of computer-assisted formulation as we move forward here. But I want to make sure that we can somewhat master the concept of just a basic Pearson square method and building the economics there before we get to the computer-assisted formulation, because you have to understand just the very simple needs and requirements and step-by-step approach to balancing a ration instead of just throwing things in the computer and seeing what it spits out. Because even though the computer will do a lot of that work for you, you still need to know that certain things can't be fed the way that the computer tells you that they might work, or there's going to be some limitations in mixing, or there are different feeds may be available than what the computer suggests that you might feed. So it's quite important that you know the background of balancing rations before we just get into playing around with the computer and telling us to spit out a ration for us. So to wrap this one up again, this slide set obviously quite a bit shorter than the last few that we've gone through. That might be approaching most of an hour of your time if you listen straight through from front to end. So some take-home messages here on this section is, again, ration formulation basics. You can do those on your own if one knows the basics of ration formulation and nutrient needs. You don't necessarily have to have a feed nutrition professional hired or pay one in order to do some of these real simple things. I'm thinking of some of you again that have maybe a horse or two out there that you like to enjoy recreationally, or some of you that maybe pick up a few calves and feed them mostly out for your own beef purposes. You guys can complete your own rations with the tools that we've talked about here in this section. So that's, it is not as difficult. You just have to get confident in your ability here, and don't be afraid to ask questions. One of the things that this is kind of one of my specialties. So don't be afraid to ask questions, because I will help you through that. Remember, again, the Pearson square method that we're teaching only does one nutrient at a time and two ingredients at a time. So there are some limitations there. But it's better than nothing, I will tell you that. And then lastly, again, computer-assisted formulation, again, much more simpler. And there are options out there actually for you to purchase some of these software packages if you think that's important for your own farm. And I know that there are a few locally that do have purchased their own ration balancing program and use it regularly on their own operation. And I know obviously many that they pay someone for that service. There's lots of very good people in our area, very, very smart nutrition professionals that can be great resources for you on the farm in order to increase your productivity and decrease your costs, and then obviously the goal being increasing your bottom line. So thank you for following along here in Unit 4 and doing some ration balancing. Be prepared for a quiz the next time that we meet, and then obviously we're going to jump in and start throwing some rations together and seeing how we can make some of these things work. Thanks again for listening, and we'll see you in class.